Okay. Okay, we are doing some Chapter 8, like final review problems, and I'm going to see if people know what they are supposed to look like. The last request was for one of the two-dimensional problems. Does anyone do you prefer the test review or the practice test? The practice test is a little more similar to the real test, I think, but they're all essentially the same problem. Okay, we'll go to the practice test, just starting here. Okay, that's one-dimensional elastic. That's also one-dimensional elastic. It's easier for some reason. Let's see. Okay, that's impulse. Okay, that's one-dimensional inelastic. Okay, two-dimensional inelastic collision. Only took us a minute to find it. Okay. To receive full credit, I must write out any equations from the equation sheet. Which one should I write down? Do you like to and do you like to make them vectors right away? Oh dear. Sure. Okay. At least. Excellent. This is the one where they stick together. It's called perfectly inelastic. So you can highlight those words, and it indicates, again, they are stuck together. Okay. Those are the keywords I like to give because it should be obvious that we always want to conserve momentum. So basically, every single problem starts out m1 v1 initial plus m2 v2 initial. You can start writing that down. Doesn't matter if you want to flip the sides, whatever. Make it your own. That's fine. But every single problem starts that way because momentum is going to be conserved. This is the special case where they stick together, and so they must have the same final velocity, so we can distribute ahead of time and just do v final. There's one vf at the end. But this is not enough, because in reality always these are vectors. When we had a one-dimensional collision, then plus or minus was enough to indicate my direction. It's all on a straight line. I did you a huge favor. If you dare to take AP Physics, you'll find out just how huge. Because the two-dimensional problems are absurd if they can bounce off each other. But okay, so this is where a picture might be helpful. So here's what I do. For my sanity, I either put my masses in parentheses, because oh look, there they are in parentheses. If I was going to draw a dot, then the mass would be a dot, and the parentheses kind of symbolizes the circle for me. And if you've been practicing these a lot, you can jump straight to calculating momentum. But for this example, I'm going to not do that. So mass 1 is 0.25. So you see how neatly that is. And because it's parentheses, that's kilograms. Like I know the units. It's only the answer that needs units. Then I'm going to multiply by the vector velocity. It's initially moving west, which is negative 6 in the x column and 0 y, plus the other mass is 1.0 kilograms. Okay, this one's moving north. So what's its vector look like? What comma what? Christine? Or sure. Okay, excellent. 0 these are, I've not created momentums yet, so these are Vx comma Vy in all these brackets. So 0 plus 2 equals, and on the other side I have 1.25, and we can still just symbolize that V final. We're solving for V final, we don't need to know or guess what it is. Okay, there's my equation from the equation sheet with everything substituted in. I would accept the momentum. I would actually accept this next, well, Okay, let's make it really convenient for us. If we've solved enough of these, and we're ready for a test tomorrow, har har har, then it actually looks like this. I would say here's momentum 1, okay, and it's going to be negative 1.5, yeah, 1.5 comma 0, and I can do plus momentum 2, it's 0 comma plus 2, and these are all in newtons. So there's the momentum. Okay, and I'm adding them together. And look, I have x and y in different columns, so it's really easy just to add down the columns. Minus 1.5 plus 2. And then that's what equals 1.25 times v final, my final momentum. So I've basically solved it, but what do I need for the answer? Find the velocity, and this one says x comma y components. So in the test review, I asked for the angle and the final speed. On the real test, I think asking for the test a day early was a foolish thing, because now today, if it's by Friday, this can sink in. I could ask for either the magnitude and the angle, vectors can be written that way, or I could ask for your x comma y, whatever I feel like. You have to be ready to do both. So if you're not going to be ready to do both on Friday, then you should vote and you should debate and lobby for the test to be a little later, so you can go back and practice these. Practice test, test review. The real test will not have choices A, B, C, D. I did that on the practice so we could grade speedily and we could discuss the answers. Any questions so far? Okay. Well, in this case, I need the XY components. So I just divide everything by 1.25 kilos. That means each bracket, each pocket in the bracket, each piece gets divided by 1.25. I'm keeping x and y separate categories, but mass is just a scalar. Mass doesn't depend on x or y. I, of course, need a calculator. Again, minus 1.2 in the x direction. Okay, and positive 1.6 in the y, and this is meters per second because it was newtons over here, momentum, and then I divided off the kilograms. Okay, and so there they are. So that matches. Watch out for choice B that just has the signs flipped. That should be A. Okay, but, so, in any 2D problem, if you've got to just start with the equation sheet right out, or the equation right off the equation sheet, fine, and then make it an extra step to make sure those are vectors. There'll be just one two-dimensional problem, I think, on the test. I don't promise two maximum. Okay, because I like to, some of these problems could be really easy, like what if the elastic or inelastic one has a velocity of 0? That makes the calculation super simple. So I try to give you one easy one of a certain type. But then I feel like I haven't really tested that thoroughly. So I might do one easy one that has the components like this, and I might do a harder one that has the magnitude, something like that. So I won't limit myself to just one, but I said on your votes, it's 6 questions total. So at maximum, 1/3 of the test is two-dimensional, and at minimum, 1/6. So not the most important topic. Sure. Let's see. Okay, here's what I mean. Whoa. Technology. There we go. Okay. So, let's see, negative 1.5 and 2. Oh, I want the top of the axis. Okay, you're not really ready to test on these. So if you just understood everything I've got now, you're not really ready to test on these until you can do this trig. Okay, and it actually doesn't matter if you do the momenta or the velocities. I might ask for either one. Okay, but if I have in the x direction minus 1.5 newtons and plus 2 in the y direction, that makes my hypotenuse 2.5 newtons, and its angle is how much? Okay, so you could say that this angle is 53 degrees because the y component is bigger. You could say north of west because here's west and here's north. Okay, but if I did physics style, the angle theta equals 0, then this angle is 127. Are you prepared to do any trig direction I feel like? To make a vector? Okay, most people are nodding, so hopefully Friday wins. Okay, but so not only do you need to make sure this is categorized into x and y, it's critical because you need to not just, it's a free response test. You need to have some reasonable idea. By the way, if you just draw this triangle and label one of the angles correctly, oh, I've got it because it's free response and I can read your math. Okay, but don't forget to do that, and don't vote for the early test. That's what I thought was foolish. Don't vote for the early test when you might panic and not be able to do something like this. Sure, Christine. You could say from 0 or from east. That's because that's the standard way we count angles in math. I could say 37 west of north. The cardinal direction system is really weird. But give the angle relative to something. If you don't give it relative to anything, I'm forced to assume that it's from the x-axis or from east. If you just list a number of degrees. Right, so numbers just written by themselves are positive in physics. We measure positive angles counterclockwise from the x-axis. So if all you did is write down a number with degrees, I have to assume that's what you wanted, that's where you measured from. Right, but notice as we go, the more details I put on this picture, the clearer and clearer it becomes. That's why there's only 6 questions on the test, so you have no excuse. You have plenty of time to put all the stuff you want on there. Try all 6 questions however you want. Good. Any other questions? Okay, let me cut the video. It's been almost 15 minutes on just that.